Alright, in this video we're going to be looking at elementary matrix operations. In other words, our simpler matrix operations. Our first objective is to add and subtract matrices. Then we will identify additive identity matrices and inverse matrices. We will also look to perform scalar matrix multiplication and to solve matrix equations. So let's get started. We need to begin by defining a few things, the first of which is what are equal matrices? They are going to have the same dimensions and have equal corresponding elements. So let's look here at this first example. We are going to find the values of A, B, C, and D given that these two matrices are equal. We can say that they're equal because they both have the same dimensions. They are both 2 by 2 square matrices. Let's get started finding the value of A. Notice the position of A. It is row 1, column 1. We're told that the corresponding element in our second matrix and that value are equal. So A is equal to 7 because these matrices are equal and corresponding elements are equal. Next, we're looking to find the value of B. Well, B is in the the first row, second column. And in our other matrix, the value there is -8. So those two elements are equal to each other. That allows us to solve for B by dividing each side by 2. So B is -4. Starting to see the methodology here? Because those matrices are equal, corresponding positions, you could say, are equal. So if we're looking to find the value of C, well, it's actually in our second matrix, but that position in the first matrix and the position where C is are equal. So we can set up this equation, and we will just add 5 to each side to solve for C. That gives us 8 for C. Now our last value is D, and D is actually in both of our matrices, and it's in the same position, so we can set up an equation here, and it's okay that D is twice. We're just going to go back to some basic algebra, and we're going to solve for D. I will add I'm going to subtract D from each side so that you only have one D in your equation. And then you can divide by 2 to isolate D, and that gives you the value of 3. So that is an application of utilizing equal matrices. We have some more information next. Important notes that we need to know about matrices. Only matrices with the same dimensions can be added or subtracted. It's like adding oranges and oranges or apples and apples. They have to be similar like that to be able to add them. So they have to have the same dimensions. And when it comes to adding and subtracting the matrices, first of all, remember they have to have the same dimensions, and then you're just going to add or subtract their corresponding elements. Why don't we try this? Here we have two matrices, and we're going to evaluate them. We're going to evaluate the expressions A plus B, so that's adding our matrices. And then we will have A minus B, so we will subtract our matrices. Let's get started with A plus B. Notice that they both have the same dimensions. They are 2 by 3, both of them. And that means that we can add them together by adding the corresponding elements. That looks like adding 2 and 4 because they are in the same position in each matrix. Adding 7 and 2, 0 and -1, that's that first row. Those corresponding elements there. You'll see in the second row we added 3 and 1, corresponding positions. 1 and -2, those are corresponding. 5 and 3 as well. Then you just simplify, giving you 6, 9, -1 in that first row, 4, -1, and 8 in the second row. Now that we've added, let's try subtracting. It is the same setup, the same process that we take here. We note, okay, they have the same dimensions, we can go ahead and subtract them. If they didn't have the same dimensions, we couldn't go through this operation. So let's begin. Like we did with addition, we're going to work with the corresponding elements, those that are in the same position in each matrix, and we will just subtract them. So now it's 2 minus 4, 7 minus 2, and 0 minus a -1 in our first row. Then we'll have 3 minus 1, 1 minus a -2, and 5 minus 3 in our second row. Simplify, and you'll have the elements -2, 5, that becomes a +1, 2, 3, and 2. Sorry if you heard some whining in the background. That's my dog, Diego. He misses Ariel. All right, so some more definitions. What is a zero matrix? Well, it's pretty much what it sounds like. It's a matrix where all the elements are 0. So every single element inside of that matrix, no matter what size it is, no matter what the dimensions are, every single one of those elements is 0. Now, a zero matrix is the identity matrix when working with matrix addition. So that is closely related to the additive inverse matrix. Now, inverses, additive inverses, when you take, let's call it a matrix A, you would denote the additive inverse as -A. And it's going to have the opposite corresponding elements of A. Now let me put this all together for you here. If you take A, matrix A, and you add to it the opposite of A, it's going to give you 0. We know that to be true. So matrix A plus, remember that opposite A, that is the additive inverse. It means that every element in that opposite of A is opposite of what was in A. And that's going to give you the identity matrix. Meaning, when you add those two together, you're going to have a matrix with every element equaling 0. Let me show you this in an example. Here we have a matrix named C, and we're going to state the additive inverse and the additive identity for it. Let's begin with the additive inverse. The additive inverse is going to be what you might call the opposite of C. So every element is going to be the opposite of what we saw in matrix C. I hope that makes that a little bit more clear. It's a lot of terminology, but once we get a hang on that terminology, I think now you see additive inverse just means the opposite values when you're adding. Now, the additive identity, remember the identity matrix is your zero matrix. It's the result of adding C and the opposite of C. If you were to add 1 plus -1, that gives you 0. 0 plus 0 gives you 0. -6 plus 6 gives you 0. Do you see how I'm adding corresponding elements in C and the opposite of C? If I do that, I'm going to get a matrix full of zeros. And it's going to be the same size as C and the opposite of C because it is what would be produced if I added those together. All right, that's all I have for that terminology. Now, let's talk about scalar multiplication. When a matrix is multiplied by a real number, that real number factor is called a scalar. Let me show you this in an example here. Let's take this matrix. It has the elements 2, -4, 0, and 7. We're going to multiply it by the scalar 3. What that means is every element in our matrix is going to be multiplied by 3. So you kind of just distribute it to each position in your matrix. And some quick multiplication would give you 6, -12, 0, and 21. And that's scalar multiplication. Let's practice this in our final example. Here we have a matrix A and a matrix B, and we're going to evaluate this expression, 1/2 A. That means we're going to multiply matrix A by a scalar of 1/2. So every element in A is being multiplied by 1/2. And you would just simplify each of those, giving you 2, 0, 1, and 5 halves. Let's do another. We're going to evaluate the expression -5b. So that means multiplying matrix B by a scalar of -5. Every position in matrix B has been multiplied by -5, and if we simplify, the result is -10, -20 in that first row, then -5 and -15 in your second row. Okay, now for one final and I should say maybe more challenging example. Let's work through this expression. We're combining what we've learned when it comes to adding and subtracting matrices and multiplying by scalars. So we're going to take matrix A and multiply it by a scalar of 3. Then we're going to subtract matrix B, which has been multiplied by a scalar of 2. So distribute that multiplication to every element. 3 times 4, 12. 3 times 0, 0. 3 times 2 is 6, and 3 times 5 is 15. Then we will subtract our matrix B, which has been multiplied by a scalar of 2. So notice that now that second matrix, every value is twice as much what it originally was. Then you just subtract the corresponding elements. So 12 minus 4 is 8. 0 minus 8 is -8. 6 minus 2 is 4. And 15 minus 6 is 9. And that's all I have for you guys in this video. I hope it was clear and concise. If you have any questions, we will discuss those in class. Thank you.